Hello everyone, November the 24th. Alright, let's do this. Oh, okay. It's similar. Smallest integer divisible by k. Okay, it's not as similar. Given a positive integer, k, you need to find the length of the smallest positive integer n, such that n is divisible by k, and n only contains the digit 1. Return the length of n if there is no such n, return -1. n may not fit in a 64-bit signed integer. So it can be huge. And we need to divide it by k. Okay. So basically, we want to find length of the smallest possible. So n is just 1, 1, 1, 1, 1, right? We want to know what's the length. So what's this length? The smallest length, such that n mod k is equal to 0. Which means we need to find k times something equal to this. And then n may not fit, so n can be huge. Yeah. If it's okay, so if it's the even number, then it's just not possible, because no even number can do this, right? It has to be odd. Okay, it has to be odd. Now it's gonna be like, if it's a 1 is good, 3, 5 is also not possible, right? So 2 is not possible. So 2 let's call it 2 times a is all not possible. 5 times a is all not possible, which means this is ending, right? 5 is also not possible. If it's divisible by 5, it's not possible. Divisible by 2 is not possible. So 1, it's triple. 3, 5. So we have 7, 9, 11, blah, 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 right? So it's all odd integers. And we need to find the smallest such that it makes sense. All right, so if I'm given a value, let's call it 2 times a plus 1, because it has to be a odd integer. So we say it times b, right? Actually, no, we want to know divisible by k. Yeah, this is a k. Wait, hold on. This is a k. So k equal to this, right? So the k times sum will equal to basically 10 to the, I don't know, return the length. So we say r, okay, because 3 will be r minus 1 plus 10 to the r minus 2 plus plus 1, right? And this part can be simplified. So this is essentially 10 to the r minus 1 divided by 9, right? Which means if r is equal to 1, r is equal to 1 is 1, right? So r equal to 1 is 1. R equal to 2 is 1, 1. R equal to 3 is 1, 1, 1, right? Okay, so what we want to find is 2a plus 1 times b is equal to this. Now we're going to do some arithmetic here. So instead of doing arithmetic, maybe we can just make this larger. So b is any integer. A is also any integer. and we want to find the smallest r. Okay, r has to be smallest. So we do multiply by 9. So be 10 to the r equal to 9b 2a plus 1 plus 1, right? So we just want to know what's the minimum r that can make this one work. And to make this one work, b can be anything, a can be anything. So we can try like r equal to 1. Okay, if r equal to 1, and a can be 0. A can be 0, 1, 2, da, 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 da. B cannot be. So B can be 1, 2, da, 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 da. So let's say A is 0. And then B is 1. Then we get it. Wait, hold on. So what we have? K. We have K. So 2A plus, so this I already have. This is K. I don't know why I do this way. This is K, right? This is K. This is non-value. This is a non-value. So like if it's 1, then we just try. If it's a 2, and we know it's not possible. If it's a 3, so it's just a 27b plus 1. Now we try 1, we try 2, we try 3. What's that? That doesn't work. Oh wait, hold on. Yeah, we just keep trying. Right? Try 3, try 4, try 5, because we just want to see if it can hit. But until what? Right? Until what do we give up? We keep going, and then we try to see if it's possible to hit. Wow, that is... So we're gonna do... Yeah, we can keep going, but when do we stop? Yeah, when do we stop? Should be all the way to 37. I mean, if we do it this way, so K we know, and we actually move this one here. So this 10K minus 10R minus 1, so 9 times B times K, right? And this I know is 9. 9 with K R minus R 9s, right? Yeah, it's R 9s, and then I can divide the 9, so this is 1 1 1 1 1 B times K. Isn't this just like that? You just swap it back to this. Yeah, it doesn't really work. You're still just trying. smallest positive integer n such that n is divisible by k and n only contains the digit 1. Let's get back to this. Okay, that's what we want. So k is a known value, right? K is a known value, and then we need something plus 1. It has to be, so this 9b times k has to equal to something something 9, right? It has to end with 9, which means b times k need to end with 1, right? B times k need to end with 1. That's the same thing. That's the same thing. You need to end with 1. All right, let me think. Okay, so 1 is good, 2 is not good, 3 is good, 4, all this, so 5 also not good, right? 7 can be, because 7 times 3 7 times 3, right? This is a possibility, okay? And the a is no good. 9 can times 9, right? 9 can times 9, well, and that's 1. 10 is no good. 11, so 12 no good, so 13. So basically we can say the n has to be 1, 3, 7, or 9, the last digit. And then 1's already done, but we have like 1, 1. That's a triple case, right? N is like 1, 1. N is already consisting of all 1. That's a triple case. Now ending at 3. K end at 3. K end at 3. So that's actually hold on. For like 13, do we have something for 13? So 13 is, 10 plus 3, right? No idea. Let's think about another way. So 1, 1, 1 mod 3 is equal to 0. 1 mod 3 is 1. 10 mod 3 is 1. 100 mod 3 is 1, because 33. So and then the sum is divisible by 3, right? So maybe this is what we can do. 1 mod 7, 10 mod 7, this mod 7, and their sum has to be divisible by 7. So this is 1, this is 3, this is, I don't know, 100 mod 7. It's 2. Right, 1000 mod 7. Is 6. So we just see if it's like 1 plus is 4. It's 12, still no good. So we keep going until I think if we keep going, this one eventually will repeat. I cannot prove it, but I'm pretty sure that's what's gonna happen. Next is 4, and that's 4, 5. Next is 5. Yes, it will definitely repeat because we cannot do more than this k, right? Well, we'll definitely repeat. So by the time when we repeat, then we will know. I think I know. Just let me double check this. Yeah, now we go back to 1. Right? So now we repeat. So we just need to know this, and we see as we add up, is it possible that this is divisible? So yeah, so about 4 divisible, no. Yes. This is divisible by 7, which means we can do 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6 divided by 7. That is very interesting. 1, 2, 3, 4, 5, 6. So basically we add. If we add a full round, but we don't see it's divisible, would it be possible that if we add another round, will be divisible? So we can add, right? Add. Or you can get, a remainder, or you can keep getting remainder, and then add the last one. We have remainder. If one round doesn't get you there, I think we need to do 2 rounds, right? If 2 rounds doesn't get you there, then it's just not gonna happen. Because 1 round, it's okay. So we do another round because we have 1 times that, and then we do another round. So we just add more. But if we have 2 rounds already, doesn't work, and then I think it will just not work because the multiple will not work. Yeah, I think we just need to do 2 rounds. Some might say we only need to do 1 round, but I'm not sure if 1 round is enough. So 1 round is k minus 1, right? 1, 2, 3, 4, 5, 6. K minus 1. So we do k minus 1 plus k minus 1. So 2k minus 2. If within 2k minus 2 we don't get it, because we'll have the sum of this, right? And then we plus more. This is kind of a new thing. We have the remainder of the previous plus 1, but once 2 rounds is done, right? Once 2 rounds is done, and then we go back, now we have 2 times the sum plus this, and that's exactly the same remainder wise as one round. So I think we only need to do 2 rounds. I think we need to do 2 rounds. All right, this is not right. Okay, there you go. All right, what is this problem? 1015. We can break down n by writing it as 1 plus 10 plus 100 plus, right, To make n divisible by k, we need the remainder of 1 mod k. We need a sum, right? Need the sum of remainders. 1 this plus 10 this plus this plus to be divisible by k. We will go around since the remainders must repeat. We will go at most 2 rounds, right, to get all possible sum of remainders. No, it's not. It's the sum of remainder get repeated. And sum of remainder gets repeated. That's not true, because you can keep adding and then you get sum, and then you're repeatedly adding the same, right? You're repeatedly adding the same, and we have some remainder, and then so it's 2 rounds. We have all possible sum of remainders. So if no n can be found after going through 2 rounds of remainders, we return a -1. Also, we can quickly return -1 if k is even or k is divisible by 5. Okay, so if k is even or k is divisible by 5, return -1. Done deal. Simple. Otherwise, we will just say what do I tell? Int res equal to 1, because you have to start with 1, and then for res equal to 1, we say the tens equal to 1, start with 1. Okay, while res is, because I go 1 round, I go 1, that's 1, 10, that's 2, right? So we do, so k needs to smaller equal to 2 times k minus 2, right? That's the maximum we can go. Tens res and r equal to 0, start with 0, right? So r equal to r plus tens mod k. If r is equal to 0, return res. So if it's 1, if k is equal to 1, then because res has to be 1, k is equal to 1 doesn't work. Well, we start with how many times? Let's just go 2 times k then. Simple. 2 times k. We'll just go through k twice. Right? It doesn't add too much, but it'll cover more scenarios. Right? We just go through k twice. No, I think technically as we go through k minus 1, right? And then we need to hit k. And then we go through another k minus 1. So it should be this minus 1. That actually makes sense, right? We start with k equal to 1, then work. K equal to 3. So we go 5 times. K equal to 3 go 5 times. Because we'll go through the remainder 0, 1, 2, 3, 0, 1, 2. Right? 0, 1, 2, 3. 0, 1, 2, 3, 0, 1, 2. That's 7. But this is giving me 5. Okay, that's not right. So 0, 1, 2, right? 0, 1, 2. 3 is 0 already, right? 3 is 0 already, so we still have to go through 3. And 1 and 2. So it's 6. It is 6. Okay, 6. It's 2 times k. Okay, 2 times k. Let's just go through 2 times k. And then we will just update the remainder. And if not, 10's multiply equal to 10. We just, get big. Because k as a most 10 to the 5th. Okay, 10 to the 5th. K is 10 to the 5th. K is 10 to the 5th. So the 10s we have to keep multiplying 10 to the 5th. That doesn't sound right to me. We cannot keep multiplying. Well, I think I can do, maybe I don't call it tens, we can call it base. How about that? Okay. We can say, hold on. I was thinking we can do base equal to base times 10 mod k. Because this is just, we just keep modding and adding, so I think this should be fine. We just times 10. Right, and then we go back up, and then if nothing happens, we'll return -1. All right, let's see if this one works. So we try. Doesn't work. Output 1. Oh, I think I forgot to res plus plus. My bad. So res plus plus. All right, let's go. 7, 9, Okay, I go this already. So 7, 9. Let's 11. That's a good one. 13. 17, 19. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right. 1, 2, 3, 4, 5. Oh, that's way too much. Probably do this. 1, 2, 3, 4, 5. I think that's still too much. No, I think that's fine. No, that's too much. Too big. The last one's too big. Oh, it's not too big. It's 10 to the 4th. Okay, I think this one probably works. Yes, works. Actually, works very well. So modulo stuff. What is this? Like this week is gonna be all modulo. It's possible. We just go full modulo. Last time 2020, and did it again at 2021. Oh, December 30th, 2021. Oh, Python. Let's see how I did this back then. No, I think this is brute force. You gotta be kidding me. Oh, but I have this. Okay, so that is what I did. How about this one? They say we only need to go through 1 round instead of 2 rounds. So if you think about it, you do a k rounds, and as you do k rounds, you must have encountered all. Actually, I don't know. I think it makes sense. You do k rounds. Given k, there must be k possible remainders. Yes, thus if within k iterations we haven't found a 0 remainder, then it is impossible. So what you're saying is it will. So we given k, if we haven't found it, then we'll never find it. I mean, I'm doing basically the same thing. The only difference is I'm using it's actually, this is the same. It's incremental, right? It's just the same. We're getting incrementally, we're getting the remainder, and we're saying if the remainder is not equal to 0, and then just keep going. But I go 2 rounds. What they say is we can go just 1 round. One round. if you don't find in one round. That's interesting. So the previous solution I had suggested that we only need to go through one round of k. Because if 0 doesn't show up in one round of k, it will never show up. So like we'll have repeats, and that's, I don't know, because each time I add new things, it's slightly different. I'm not sure about this, but apparently it worked. It works. So I do that. I do base. I do R. So I say, well, this is smaller than this. R is, actually I don't even need to do R, right? So R is going to be equal to R times 10. So R times 10 plus 1 mod this. I'm not very convinced, but I guess it makes sense, right? I guess it makes sense. I can conclude that remainder repeats. Okay. I don't know. I don't know about that. But my other solution definitely makes more sense, right? My other solution makes more sense. It makes sense to me. And this one, yeah. Anyway, that'll be it. We got it done. I'll see you guys tomorrow.